Hi guys, welcome to COSC100 Tutorial 7, exercise number 2. And in this exercise, we're going to be working with our employee and department tables within the Postgres database management system. And we're going to create some records in those tables as we did in the lectures, and we'll then construct some queries to extract the data out of those tables. So to start this exercise off, we're going to first create the department and employee tables that we were working on in the lectures. Now we're going to start off by creating the department table because the employee table has our department number field that references the department table. So if we try to create the employee table first, we'll end up with a referential integrity error. So we'll start by creating our department table. So I'm just going to copy this code directly from the exercise, and I'm going to open up an SQL worksheet that I can drop my queries into here. So just let me move this around a little bit. So if I paste that one in, zoom in a little bit here, you can see that I've put the table create statement in. Go and execute that one, and that one executes without error. I'll then insert some records into that table. So again, go and grab the 4 insert statements for each department record, drop them into my SQL worksheet, and insert those records. Now I can go and double check that that's been created correctly by going and reviewing my database, and I can see that I've got a department table here, and if I view the records in here using the view data tool, I've got my 4 records of data entered into my database as expected. Just need to quickly repeat the same process for the department, for the employee table. So we can go and grab the employee table definition, and I'll drop it into my SQL worksheet. So recall that the employee table, it has an ID number that we're using as our unique identifier. It's got a first name and a last name field, and we're making those character fields. It has a date of birth, which is a date, and we have our gender field, which checks and accepts either a capital M or a capital F character. We then have a real type representing our salary, and then we have our department number that references the department table, and it references the D number field from the department table. So that's why we have to create this employee table after we have the department table. So we'll drop that in. We can see that query has been executed. If we refresh our tables over here in the Explorer, we can see that we've got a nice employee table with no data in it. So if we go back and grab the insert statements for our rows of data, drop them back into our SQL worksheet, put the cursor back up on the top row, and run through and execute our statements. And when we do this, we should end up with our rows of data in there. So we've created our little employee database that consists of employee records that point to some department records in our department table. So that's the first part of exercise number 2 already completed. The next exercise looks at creating some queries. So the first query asks us to return the first name and last name of all employees from departments located in Sydney. Now, if we look at our database table definitions, we can see that the first and the last name fields are in the employee table, but the department table is the one that stores the location field. So if we want to search by location, we're going to have to join these 2 tables together. So we'll start by selecting the fields that we want. So we want to select the first name and the last name fields. Now we're going to need to join our 2 tables together. So we're going to join employee we're going to join our employee table to our department table using an inner join. And we're going to join on our department number being equal to D number from our department table. So we can see we've got department number from our employee table pointing to D number from our department table. So we need to then put a where clause in. So recall that we're filtering in our question where we've been asked for employees from departments located in Sydney. So we're going to be filtering based upon the location field. Now, the location field appears within the department table, which is fine. We've already included that in our query here. So now we can start building up our query. So we're going to just going to separate my query over multiple lines here to make it a little bit easier to see. So our where clause will appear at the end, and we just need to go where location is equal to Sydney. Now, if I haven't made any mistakes here, this should run correctly, and you can see that we've got 6 records returned here. So you can go and double check those records to ensure that they actually all do come from a department located in Sydney, but we've joined our tables together using our inner join, and we've filtered on our location, so we should have the correct results displaying here. The next query asks us to return the first name, last name, and date of birth for all male employees from departments in Melbourne. So again, by looking at the fields involved in our query, we can see that the first name and last name all come from our employee table, but the location field that we'll be using to filter comes from the department table. So again, we just need to go and we might grab the start of our first query and drop it in and just alter. We might just add the date of birth to this one, so it should be just date of birth. Again, we're just joining our employee to our department table via a department number, and now we just need to go and construct a where clause that reflects the conditions here. So we want the gender, where the gender is equal to capital M, and so we have to meet both conditions. So we have to have male employees from departments in Melbourne. So again, we'll use our location field to grab Melbourne. Now, when we do this, we might find that there's no records returned. Oh no, we've got 2 records returned for this one. So, so you can see that as we move down and move down with more and more conditions, we get fewer and fewer records returned from our database. Now, the next query asks us to return all employees from the research department that are born after 1975. So again, we're having to join our 2 tables together because we're identifying a department by its name, and we're going to be filtering on the date of birth. So in this situation, I haven't specified any fields, so we're just going to return all fields. So I'll start off a new select query, and we're going to select all fields from, and again, we're joining our 2 tables together. So we're joining our employee table to our department table. So I'm going to grab that same piece of code from the original query up the top. And our where clause, so our where clause is going to make use of our department name field. So I'm going to grab the department name, and we want that to be equal to research. And the second part of our filter uses the date of birth. So we just need to go and grab the date of birth field, and we want that to be greater than 1979/month/day. So in this situation, we want to retrieve all records. Oh, it's 1975, not 9. Sorry about that. So in this situation, we're grabbing all of the records that have a date of birth after the 31st of the 12th, 1975. So recall that when we're working with dates, that we have to put we put our date in the year, month, order format, separated by our dashes. So now when we run this query, you can see that we get all of the rows returned from both table. So we've got all of the employee fields returned because we haven't specified any particular fields, and we've also got all of the department fields returned as well because we've joined these two together to create one big relation or one big table that we can select and filter on, and we've of course put our filters in there. So recall that our filter here specifies that they have to be both from the research department and born after 1975. So we've used the greater than symbol there, the greater than operation, to find records with a date of birth greater than 31st of the 12th, 1975. So we'll move on to the next query. Our next query asks us to find the maximum salary across all employees. So in this situation, we have to use one of our aggregate functions because we want to summarize multiple records into a single record. In this situation, we're going to be using the max function. So to do that, all we simply have to do is start a new select statement, and again, we're going to be selecting the max of our salary field. So the salary field in the employee table is referred to as the salary. And we're doing this, we don't have to join our employee table to our department table in this example because we only need to use the salary field. We don't really care what department they're in, so we're just going to select that from employee. And that's all we should need to have in our query. So we can see here it's actually made the column a little bit narrow. So we've retrieved the maximum or the largest salary from all records in our database here. Now we can check that ourselves. So if we go to our employee table, very quickly you'll see that the largest salary up the top here is the 150,000. So we've used the max function to summarize all of our tuples, all of our rows, down into one single individual measure there, one statistic. So now the next function, the next query that you've got to construct also makes use of our summary operations. In this example, we're returning the average salary across all employees based in a department from Sydney. Now, if we go back to our first query, we can see that we've got most of the bits and pieces we need here. In this example, we're grabbing the first and last name from all of the employees from departments in Sydney. So we can go back and revisit this query. So you can see here we've got our inner join between the employee and the department table, and we've got our filter for location equals to Sydney. So all we need to do here is replace what we're actually selecting from this set of tables. And we can do that. Of course we want to grab hold of the average salary, so we're going to use the average function here. And if we just put our salary in there, we can of course drop that in. Oops, it should be AVG, I think, sorry. Just give that one a run. You can see there, sorry about that, it's actually AVG, not average. You can see that we've found the average salary for all of the employees based in a Sydney department. So we've used the average function to summarize all of the employee records that we originally returned in our first query down into a single statistic, a single average. So we'll comment that one out. Now we can move down to the next query, which asks us to return the first name and last name fields of all employees ordered by date of birth. So we want to go from the oldest to the newest. Now we can do this by using the order by statement. So again, we're not joining any tables together here because we don't need any of the information from the department table. So we can just construct a select query that grabs the first name and last name. Oops, we don't need that. From our employee table. And we're going to use the order by operation, and we're going to order by date of birth. Now we want to go from oldest to newest, so the newest dates will be later than the oldest dates, so this should order things as we want them. So you can see here, we might actually display the date of birth just to do some checking on this one as well. So you can see here we're starting with the oldest dates of birth and ordering them right up to the youngest dates of birth, so we don't need to include that in. We've checked our query results, and that gives us our final result. So we've gone through all of the queries there for exercise number 2. So this will be very useful for the upcoming assignment, the upcoming databases assignment. So that's all I've got for exercise 2, and thanks for listening.